Okay, so good morning, everybody. Welcome to the Bruker webinar. So I'm Haley Hoffman. I'm the product category manager here at Nelson-Jameson. So super excited to have Cassandra here from Bruker to talk about the FT-NIR technology that Bruker has to offer the dairy industry and what it can do for all of us. So we do have everybody muted right now. So I just ask if you guys do have questions, just send them in the chat and then we can moderate those and talk about them at the end. So I'm going to hand it over to Cassandra and turn my video off and let her take it away.
Good morning, and thank you, Haley. I'm excited to speak with you all about the move from FT-IR to FT-NIR for the dairy industry. As Haley mentioned, my name is Cassandra Bolter, and I'm an application specialist for Bruker Optics. And I'm actually an academically trained poultry nutritionist. And while eggs are on the same supermarket aisle as these dairy products, they do vary a bit. I was actually first introduced to FT-NIR when I was at the University of Georgia, and we used it to assess nutrient quality. But thereafter, I became part of the Bruker team in early 2022. So enough about chickens. Why are we all here today? Well, as the dairy industry has expanded, new challenges have surfaced as it's become more critical to keep up not only with the volume that's demanded, but also the quality of these products and therefore our control over the production process. So we know that raw milk is a price sensitive product, and in order to be profitable, everyone in the process has to keep costs down while still hitting quality targets. So how do we do this? Well, manufacturers must increase operation efficiency through the improvement of process control. But in order to do this, they need highly reliable technology. You need to streamline analyses and make immediate adjustments if necessary. You need full plant efficiency, such as to speed up mixing times and decrease drying times. And in the realm of manpower, they need to reduce mundane and time-consuming tasks. And they must also optimize blending, such as for cheese milk standardization, and again, hit quality targets and remove excess costs by reducing variation. So what are the solutions that get us there? Well, in the 1990s, we saw FT-IR set a new standard. So trials of precursors to these FT-IR instruments for low viscosity dairy products between the 70s and 90s weren't providing the accuracy and the precision that's required of this industry. Essentially, the wavelength accuracy and the signal to noise ratio couldn't support the accuracy that was needed, and the scans took a really long time to complete. So when FT-IR was able to improve upon these and increase scan speed, it made it competitive with traditional wet chemistry methods. So since we could then have that accuracy with greater speed and thus better control of our processes, we could see improvements in final product quality. Then FT-NIR made its mark starting in the later 2010s and is continued to grow in popularity as a result of some really unique advantages. So advantages that allow for it to meet 100% uptime requirements, direct calibration transfer from instrument to instrument, and other aspects that allow this technology to serve as a sustainable choice for analysis, both due to its design and limited consumables. And quite notably, the introduction of a 3-in-1 benchtop instrument into this industry, as recently the analysis of milk by NIR has gained more and more interest because of the ability to utilize only one instrument in the lab for all kinds of samples. So today we're going to walk through each of the solutions that we offer at Bruker, but we're also going to be diving into basic NIR theory and what differentiates FT-NIR from FT-IR. And while they both have the benefit of FT technology, there are great distinctions that will shape how we can utilize these instruments and, of course, what we can come to expect from them. And then after that, we're going to open up a Q&A session where you're welcome to ask all the questions. So traditionally, the dairy industry has utilized FT mid-IR benchtop instruments, which from here on forward, I'm going to try to keep it consistent and refer to them as FT-IR. whereas dispersive NIR systems are used for inline analysis. And Bruker, on the other hand, offers FT-NIR technology for both benchtop and inline analysis. And all of these systems are full NIR range spectrometers, utilizing 4,000 to 12,500 wave numbers. And since they're all based on the same FT-NIR platform, users can choose the right analyzer for any job without having to compromise on precision and accuracy. So what we've had displayed here, we have our Tango R, which is a solid and slurry only analyzer, so such as for milk powders and yogurts and cheeses, while the MPA2D with the LSM2 can be configured to handle all three types of products, so your liquids, your viscous, and your dry products. And this is important because there's no other system on the market that provides this all-in-one technology. And for those looking towards the future, we also have the Matrix F2. This is Bruker's multiplexed inline analyzer that gives minute-by-minute readings for even greater process control. I did want to touch on that all of our systems have been verified by ISO standards, and a new bulletin in IDF was released in 2019 actually discussing this technology. So where do we start? Well, I think we should begin with a product that most of us couldn't live without, and that is cheese. It comes in a variety of consistencies with varying moisture content, all of which we can be analyzed on our Tango R. And these NIR measurements can be carried out in easy-to-fill Petri dishes, as we have displayed here. While grated cheese can be easily poured in, softer fresh cheeses can actually be smeared into the dish. And samples are measured with our sample rotator here. So we can scan a larger sample area, which is going to enhance the reproducibility of our measurements. But our Tango R doesn't stop there. We can also analyze other solid and semi-solid dairy products, such as yogurt, butter, milk powders, and milk protein concentrate, which is in part why it's the most commonly used instrument in food and agricultural plants. And its popularity is also because the Tango was designed with the agricultural industries in mind, serving as, our least cost product available in the market, as well as the most intuitive to use. So it's icon based, which makes it really easy for operators to navigate through the software. And we always like to pinpoint that there is no technical training required for this. And because of that, it eliminates operator variation that could occur, and it's thus going to contribute to more consistent results. In addition to that, with our Tango here, we're able to measure multiple constituents simultaneously, such as dry matter, fat, and protein. And depending on the type of cheese, additional parameters such as salt content and pH value can also be analyzed. Another thing to note is that tailored calibrations can also be developed either for a broad range of cheeses according to type or for a single dedicated product. And as I have displayed in the right-hand corner here, with the turn of a knob, maintenance is truly as simple as changing out a light bulb. But what if you're looking to do more? Well, look no further than the MPA2D and its great versatility. The MPA2D sets a new standard because it not only allows us to measure solids, such as our dairy powders, cheeses, and paste-like samples via the integrating sphere, but it provides state-of-the-art analysis of raw milk and highly viscous liquid milk products, including those which can contain particles or sugar crystals. And as we'll see shortly, the LSM module includes both a homogenizer as well as a peristaltic pump. And whether the liquid sample is homogenized on the way to the flow cell or simply pumped with the peristaltic pump is completely software controlled. So this way, the various types of liquids that can be analyzed in transmission, regardless of viscosity or the content or size of particles. And what this combination provides is a complete solution for any type of sample in a dairy lab. So this is reducing the number of instruments needed, potentially down from 2 or 3 down to 1. So here's a breakdown of our MPA2D. On the right side of the instrument, we can measure solid and paste-like dairy products, whereby we can put on the integrating sphere module, which we can analyze our powder samples in cups, or in the case of our cheeses, those disposable Petri dishes that we talked about, or glass or quartz Petri dishes. On the left side of the instrument, we have the liquid sampling module, what I referred to as the LSM earlier, which is our dual system allowing either for the homogenation of a sample or a simple pumping through that 1,000-micron path length flow cell for analysis. Now, the LSM provides excellent precision by analyzing raw milk sample volume that is more than 20 times larger than can be done by FT-NIR analyzers. You can see our 1 millimeter flow cell here, which allows viscous samples like concentrates to be easily pumped. And we also have full software control with configurable sampling volumes and automated cleaning cycles, as well as visible tubing for really easy inspection. So you can see how this is the optimal solution for raw milk due to the semi-automated sampling and the sample transport during which the raw milk is preheated and homogenized before measurement to ensure we get that high precision and repeatability, and again, followed by the automatic cleaning of the system. Another thing to point out is that with this multi-purpose analyzer, we observe both phenomenal accuracy as well as repeatability. And we can see this when we look at the validation of our raw milk calibrations. So where the LSM module and the calibrations for raw milk were checked with certified standard milk sample sets from Eurofin's DQCI here in the US, that's what we're looking at. And what we're seeing is that these results show excellent accuracy and linearity for both fat and protein. And beyond accuracy, we can also see that we're getting fantastic repeatability. So in the table on the right, we're looking at a standard deviation of 0.005 across 6 individual DCQI standards run in triplicate. And we've actually seen similar results when comparing total solids and heavy cream between the MPA2D and the reference method, which again brings to light the importance of the flow cell for our MPA2D, because not only is the size of the quartz cell important, but it's imperative to note that it's not calcium fluoride. Again, the flow cell is 1 millimeter, so with this greater path length, there is less risk for getting clogged. And also because it's quartz, it does not wear over time, whereas calcium fluoride is a salt and can be degraded by total solids in a product. So this is the reason why vegan milks, ice creams, and other products can be measured without any drift. And this is an advantage we're going to actually be circling back to. So what if you want to monitor your process more efficiently? Successful dairy inline applications can occur from raw milk receiving to finished product testing and everywhere in between. Ideally, if you're able to pick your key areas where you need the tightest process control, these will give you the greatest return on investment. And for a lot of facilities, this is going to be in some blending or drying stage. For instance, in the case of milk powders, it's important to monitor moisture, fat, and protein to not only maximize the moisture content and increase product consistency, but also to most efficiently utilize energy in terms of dryer optimization. And in the end, again, reduce your final product testing costs. So what's the analyzer that gets us there? It's our Matrix F2, which is a 6-channel multiplexed analyzer. And what this means is that you can analyze up to 6 points off of one spectrometer. And this is incredibly unique to the market. And in particular, it lowers your cost per analytical point. So on average, most of our systems sell with a minimum of 3 analytical points. So globally, we're looking at about 7,500 analytical points analyzing products today. And this really lowers your total cost of ownership, especially in light of the general robustness, and the minimal maintenance required for these analyzers. They're not sensitive to vibrations, which makes them ideal for the production floor. And we're going to circle back to how this plays into our ability to directly transfer calibrations from one analyzer to the next. Specifically for the dairy industry, we have 3A certified reflection probes and 3A transmission probes. Now, picking your probe location is what's either going to make or break your success, but we do have guidelines and, of course, always recommend an on-site visit to best spec out your system and make it successful. So just a little bit of background on the probes. The top probe, the Q413, does semi-solids and solids and reflectance, while the probe display at the bottom is going to be analyzing your liquids and transmission. So for milk standardization, for inbound receiving, for vegan milk drinks, and so forth. And the 3A transmission probe is going to be used for your less viscous products, such as raw milk, pasteurized milks, cheese milks, whey products, and any blended drink products. Again, we can see the ability to uniquely connect both solid and liquid probes to the same analyzer. So here we have an example of a 6-point multiplex system. The Matrix F2 can be connected to different types of probes with different fiber lengths. So this makes the system completely configurable to your needs, where you're not having to pay for more than what you need. And again, by utilizing only one spectrometer, your cost per analysis goes way down, such that in most cases, this makes it possible to get an ROI within 3 to 6 months after implementation. Here we have an example of multiple kinds of probes and how we install the inline systems. Some are inline, meaning the probe is directly put into the manufacturing stream, and some are online, meaning some probes are installed on a bypass loop. And again, designing your unique system is something that we're going to be there to assist you with, as we're going to help you decide on the best configuration to fit your needs. So we spoke about needing to improve process control and thus our yield. And on the right, we see that displayed for us where you can note the opportunities to control the powder in the fluid bed dryer and the spray tower feed, either control of the spray tower feed or alternatively at the feed tank by a transflection probe. And we can also have contact-free powder analysis via probe head at the sifter of the fluid bed dryer. This online powder analysis directly impacts the yield simply by analyzing moisture, along with additional parameters such as protein, fat, and lactose content. So in a situation where we normally turn to a production lab to run moisture analyses, which are, again, they're going to be run every few hours, we can now obtain moisture results every minute with an accuracy of 0.15%. So it's comparable to the Carl Fisher reference method. And with such monitoring, the moisture content can now be adjusted closer to our target value with even greater consistency. And not only do you see direct cost savings due to increased yield and reduced energy costs, but the risk for out-of-spec production is going to be greatly minimized. And the convenience of inline and real-time results doesn't end there. We're able to see these results in a multitude of ways, either locally through a product view chart in CMET or in table form, so that you can see all the measured values for a single product, or through a variety of I/O protocol options that allow you to send data back to a control room. So with our benchtop solutions, lab personnel can quickly and easily analyze samples. And this is going to dramatically increase the total number of samples that can be tested each day. And should you decide to go inline, FT-NIR can then monitor continuously. But in either case, more frequent testing results in tighter control, which again, it's going to allow dairy companies to see direct cost savings, whether it be through more precise standardization of milk, consistent control of fat content in cream, the optimization of moisture or total solid content in cheese, yogurt, or butter, or tighter control of protein, fat, and total solids in spray tower feeds, and again, moisture content of milk powder in the fluid bed dryer. So no matter where you're looking to focus in your process, there's an instrument that can help you reach your quality targets. And again, since all of our instruments are based on the same FT-NIR platform, you can select the proper instrument for the task with the same precision and accuracy, regardless of the model, and even transfer calibrations across instruments. And this is an imperative distinction that we're going to get a better idea of as we dive into what is my favorite part, which is basic NIR theory and the distinctive advantages that FT-NIR offers the dairy industry. So, how does NIR work in practice? For starters, NIR is a secondary method of analysis. So what this means is that it uses wet chemistry or another reference method to generate values. And ultimately, the NIR is only going to be as good as the wet chemistry that it's based upon. And the basic way this works is that a set of samples are run on NIR and their spectra are collected. These same samples are set for wet chemistry, and those spectral files that we collected are assigned with the wet chemistry value. So those two aspects are married together. And from here, this data can be utilized in calibration software, such as Bruker software, which we call Opus, and a PLS model can be generated. And this model goes through many validation steps, and once it's determined to be ready for production, it's going to be loaded onto an NIR instrument that is then able to predict most unknown samples in less than a minute. Here, we just have the workflow boiled down for you. So we've taught the software what we want to know, and once we have an established calibration, we could use it to predict our unknown samples. And fortunately, a lot of this background work is already done for you on basic calibrations such as raw milk, pasteurized milk, and cream. However, we still need to validate the results. So in order to do this, we simply validate the system with DQCI standards and often calculate a setup bias and then apply it to your calibrations, and then you're ready to run with no additional adjustments. And should it be the case that you have a product that is unique to your company, we're then going to pair you with an application scientist for proper method development. So what I often like to throw out there is it really a stretch to say that FT-NIR is as simple? It's not a stretch, but we do need to dive a little bit deeper. So some of the audience may already be familiar with how we utilize IR in assessing analyte concentrations and thus quality, but how does IR actually work? So IR is a type of vibrational spectroscopy that utilizes the infrared or IR portion of the electromagnetic spectrum to extract quantitative information about a specific analyte. So more specifically, the infrared light activates vibrational motions of certain covalently bound molecular bonds, including oxygen-hydrogen, carbon-hydrogen, and nitrogen-hydrogen bonds, which are commonly found in most of the food products we work with. And these motions occur at different frequencies and intensities across the IR spectrum. And within these motions, unique to individual molecules, the information about the substance being analyzed is contained. Now, when we talk about FT-IR instruments, we are usually referring to those instruments that use the mid-IR region of the electromagnetic spectrum. That's between 4,000 and 400 wave numbers, where NIR instruments use the region from about 12,000 to 4,000 wave numbers. Beyond that, another key difference between mid-IR or IR and NIR is that mid-IR is characterized by strongly absorbing fundamental vibrational transitions, where NIR is characterized by overlapping overtones and combination bands. So what does this actually mean? Well, we're talking about vibrational spectroscopy. So if we think about a vibrating string, such as when you pluck a guitar string, you're playing a fundamental note, and that's what you're going to hear the most loudly. But if you let that string vibrate, you can hear much fainter but higher pitched sounds, which is what the overtone is. It's just the repeat of that fundamental note at a higher frequency, and it's not as strong. So just as you don't hear that note as strongly as the fundamental note, the overtone doesn't absorb as strongly. Now, this slide illustrates that difference in intensity of the absorbance for the overtones and combination bands of the NIR region compared to the IR region. So it's just giving you a visual of what we kind of just covered. And this ends up having some advantages, as the lower intensity absorbance allows us to measure through a longer path length and evaluate a more representative cross section of a sample. Moreover, the NIR spectrum can be measured through glass or quartz because its materials are transparent above 4,000 wave numbers. So this has a couple advantages. One we'll actually talk about shortly when we compare the mid-IR flow cell to the NIR flow cell, but it also allows for more types of applications to be possible. And it also introduces the opportunity to use fiber optic based process probes and sensors for inline analysis, as we saw earlier with our matrix F2. But for now, I just really like us to focus on flow cell construction and path length. So this may be new to some people, so I will take my time with this. I don't want anyone to get too wrapped up in the equation you're seeing, but I do want to talk briefly about how the light absorbance can be used to quantify the important constituents that make up our dairy products. So we have a source light that is used to irradiate a sample. And as the light passes through the sample, certain wavelengths are absorbed at varying intensities based on the unique properties of that sample. And the light that reaches the detector contains information about the sample that we can then use to quantify concentrations for our different constituents. And mathematically, we use a formula called Beer's law, which calculates the concentration from the absorbance, so how much of the light is absorbed, the path length, so the distance the light travels through the sample, and the molecular extinction coefficient, which is just the numerical expression of the unique absorbance properties mentioned previously. And what's important is that the absorbance coefficients for the first overtone and combination bands in NIR are more than 1 magnitude lower than for the mid-IR range. And because of that, our path length, D, can be expanded significantly. So for example, to our 1 millimeter transmission flow cell. And that's why we can use that for our different milk and milk-based liquids. So when we think about the main differences in applying FT-IR and FT-NIR for milk and liquid dairy products, we think about the design and procedures for our transmission measurements. Now, the average diameter of the milk fat globules in raw milk is around 4.5 microns, and a homogenizer valve is used to disperse the globules to a more uniform size. So they're usually about 1 micron. And this is done for both IR and NIR instruments in order to increase repeatability and accuracy. However, as we discussed, because the fundamental vibrations in the infrared absorb so strongly, FT-IR is limited to flow cells with path lengths of 35 to 50 microns. So for liquid dairy samples with higher viscosity or small particles that are not suitable for homogenization, FT-IR measurements are no longer possible. So by using NIR and a 1 millimeter flow cell, a higher and more representative sample volume is analyzed. And this reduces the need for homogenization of every sample that you're going to analyze. So liquids with higher viscosity, such as concentrates, condensed milks, milk drinks and infant formula liquid can be just easily pumped through by the peristaltic pump. And another important distinction is that most IR flow cells, again, use calcium fluoride as window material. And while these flow cells can handle milk and low viscosity liquids, other products are going to require more extensive sample preparation. And over time, these IR flow cells are going to be affected by cuvette wear. So this means the path length we just talked about is increased over time due to abrasive components and water in the sample. So what this does is it requires more monitoring and frequent adjustment by validation and standardization procedures. In essence, it's the reason why you'd have to frequently bias an IR instrument. However, for NIR flow cells, the cuvette material is quartz, which is resistant to any wear over time because it is not dissolved by water, solvents, or any component of milk or dairy liquid products. And additionally, the particles have no abrasive effect on the inside surfaces of the cell. So, what does this have to do with the integrity of the measurement? Well, again, let's think back to Beer's law. From Beer's law, we can see how changing the path length can impact our results. And this is especially true when the path length is already so small to begin with. And as that calcium fluoride cell deteriorates over time, frequent bias, slope, and offset adjustments are required to maintain accuracy of the measurement. And it's also why these cells need to be changed out frequently. So between monitoring for biases and making calibration adjustments due to cell wear and inevitably replacing these cells on a frequent basis, that's a lot of effort to account for a variable that is avoidable with an NIR quartz flow cell. These quartz flow cells have a long lifetime and no regular exchange is required so long as, proper cleaning procedures are applied. And since that path length D, going back to our equation, is going to remain the same, we'll experience no inherent loss of accuracy over time when we use these quartz flow cells. We can again see this advantage when we look at the high precision of fat and total solids of ice cream premix displayed here. So there's no sample preparation required, so we can measure this product as is in less than a minute. And again, these ice cream premixes are not going to degrade the MPA2D's flow cell at all. There are also measurement conditions that we must take into consideration when comparing FT-IR and FT-NIR. So for FT-IR, pure water or zero solutions are measured to eliminate the interference fringes and to compensate for the spectral contribution of water. And we can see that in the right graph where our corrected sample spectrum is shown in blue. And these zero solutions are actually another source of potential error. And again, it's another aspect that does not have to be considered for our FT-NIR measurements. Because for the evaluation of NIR spectra, no compensation for water is required, which we can see on the left graph. And for NIR analysis, the flow cell is actually retracted and a background measurement is performed with an open beam or air and not through a flow cell that's filled with water. So we're eliminating potential sources of error as well as mundane tasks for lab personnel. So what can we take away from all the advantages we just covered? Well, with respect to the MPA2D compared to conventional FT-IR milk analyzers, we see it there's no standardization required either between instruments or over time. We also don't have to regularly replace the flow cell as our MPA2D's flow cell is not affected by deterioration. We also don't need to homogenize every kind of sample. The homogenizer is only required for raw milk to ensure high repeatability. And this also translates to a longer lifespan of the homogenizer valve. And thanks to the properties of our flow cell, we're also able to measure samples with high total solids. And again, we have the ability to visually monitor our sample tubing. So From raw milk to finished dairy products, you can test the full range along the production chain with just one easy-to-use FT-NIR analyzer. But these benefits don't stop at our benchtop. In 2021, Hilmar Cheese published an abstract in the Journal of AOAC, actually discussing the Bruker inline systems. And they also supported the claims that no calibration adjustments were needed during the 6 months of the study, and that calibrations directly transfer. We could largely attribute this to the composition of the flow cell, but there are other aspects that are contributing to the direct calibration transfer. So why is it that we're able to achieve this? Well, for starters, the Bruker instruments specifically have stability and reliability over time due to our wear-free cube corner interferometer. Our FT systems have this patented cube corner technology. And the key takeaway here is that reflection occurs in different spots as flat mirrors change or as vibrations occur. But with a cube corner mirror, the light goes to the same spot, regardless of age of the system or process vibrations. So what does this mean? Well, it means that vibrational effects are minimized, especially for inline products. Moreover, the instrument maintains the wavelength accuracy over time, and that's our precondition for successful calibration transfer. And because of the cube corner design, we don't have any yearly preventive maintenance or service required in order to align these instrument optics. So our analyzers are designed to be easily maintained by the user, and again, to minimize downtime and minimize your maintenance costs. In addition to this, the wavelength or x-axis scale is established using a monochromatic laser beam, and the wave number of this beam is adjusted according to an atmospheric moisture peak. So that's sitting at 7,306.74. And it's at a resolution that is orders of magnitude more precise than the resolution for routine operation. And it's because this high precision eliminates the issue of x-axis drift. And this is a really common problem among other spectrometer designs that rely on mechanical prisms or grating. So this allows for seamless direct transferability between instruments, including the ability to transfer between benchtop and inline systems in many cases. So you can see how one technology can cover every aspect of your dairy production process, and how ultimately, once you set up an FT-NIR system with a robust calibration, you don't need to regularly bias or make slope or offset adjustments due to your flow cell. Your system's going to stay stable for life, not only due to the inherent advantages of FT technology, but due to the extended lifetime of the quartz flow cell. And if there is a change in prediction accuracy, it's going to be due to process or product and not due to wear. We also have great versatility due to the LSM module on the benchtop MPA2D. Not only do we have both a homogenizer and our peristaltic pump, but the larger tubing allows for those more viscous samples to be run. And again, these are permanently aligned dairy analyzers thanks to our cube corner design. So we're ensuring the integrity of our data regardless of its environment and minimizing the maintenance that's going to be required. What this also means is that most calibrations are directly transferable. Again, you do not need to have a bias for each individual instrument, and it streamlines our ability to move from an application from benchtop to inline analysis. And this not only translates to cost savings, but it also minimizes the time and effort you'd otherwise spend individually biasing instruments or modifying calibrations to suit a different instrument performing the same analysis or placed within a different process environment. So what are our key takeaways? With our portfolio of the different FT-NIR analyzers, we see the lowest total cost of ownership between the savings on maintenance costs, direct calibration transfer, and our all-in-one MPA2D that can measure both solids and liquids, you're eliminating the need for multiple instruments. And lastly, for our Matrix F2, this allows us to connect to different types of probes with different fiber lengths. And again, by utilizing only one spectrometer, you have markedly lower cost analysis, or cost per analysis point. And we get the same benefits of incredible accuracy and precision as we typically see with FT. We also get a myriad of applications that can be measured and processes that can be optimized. And most importantly of all, it's with confidence. Thank you all so much for your time. I'd now be happy to answer any questions that you may have for me.
Okay, so this is Haley again. I'll be kind of taking a peek at the chat, but I did have a quick question for you, Cassandra. You talked a lot about maintenance. What kind of maintenance can you expect with these? Is there, a PM program that you guys offer, or what does it look like?
Right. So across the board, the maintenance for these instruments is really quite minimal. And again, in large part, that's due to our cube corner interferometer. It's maintenance free, and that doesn't require yearly PMs. But the maintenance items that we do need to be mindful of are all easily accessible by our end users. So for our Tango, that's going to be replacing the source. And again, that's as simple as changing out a light bulb. And it's going to provide you with a warning when it's time to do that, by the way. And similarly, with our desiccant, you'll also be warned when that needs to be changed out. You'll just simply unscrew the cap at the back of the instrument, pull the desiccant out, and replace it. And this is why we often recommend that customers have two on hand. So once you replace it, you can remove and regenerate the beads and the other desiccant for future use. Now, for the MPA2D, it's rather similar, but it's the LSM itself that we need to focus on, because that module is a pump. So you'll account for the homogenizer valve, tubing, the diaphragm, and then cleaning solution. And so I think we typically recommend every 6 months for basic PMs for the MPA2D due to the LSM. But of course, it's going to last longer if you're really good about cleaning it. And we do have service partners that we work with to assist with these aspects. Now, for our inline system, the Matrix F2, the light source we replace about every year, and that desiccant cartridge, again, about every 6 months. And I didn't mention this with the Tango, but it's the same concept, but it's going to depend on the environment, right? So if you are in a humid, hot environment like I am down in Georgia, you might have to replace it more frequently. But also because of the different configurations that we have for the Matrix F2, the requirements for PMs do vary a little bit. So that would be specific to the customer.
Okay, thank you. I do have another one here. Can people self-develop calibrations themselves?
Yes. So for this process, we are here to assist you through every step. So if you're working with a product that can be accurately measured by NIR, typically we like to be in the loop on that. And then we're going to assign an application scientist to work with you. So sometimes it does just come down to further developing or modifying an existing calibration that you may be looking to utilize, where we'd only need to roll in some of your data to create a model that represents your product. So it is good to keep us in the loop due to that, because we might have existing data or calibrations that can help you. But if you're curious about, the exact number of samples, because that comes up a lot, there isn't a set number that I can give, because it really depends on the application. So for instance, you need to take in mind the expected variation of the product that you're working with and the range that needs to be accounted for, because those factors have to be represented in order for you to have a robust calibration that's going to be able to predict those sample types.
Okay, and I'm seeing one more here. Can these instruments analyze plant-based drinks?
Yes. So for instance, we do have a package specifically for plant-based milk drinks, such as oat milk and rice milk. So due to that 1 mm flow cell, we're able to easily measure these products in transmission. Now, it does depend on the parameters you're interested in assessing, as we do have calibrations for other types of plant-based milk drinks, depending on what you're looking to assess. And again, should it be a product that we don't already have a calibration or package for, we can also tailor existing calibrations with similar products or self-developed calibrations.
Okay, thank you. I think that's it for questions right now. If anybody else has anything, feel free to send it in the chat. Otherwise, I think we're ready to wrap up.
Wonderful. Thank you so much for having me today.
Okay, thank you. Oh, I'm gonna end.